All right, here we go. April 27th, the week of April 27th. We're comparing functions, two things this week, comparing functions and then reviewing factoring. First part of the week is comparing functions. You know, like the back of your hand, linear functions, straight line, slope, y-intercept. You know pretty well exponential functions, exponential growth, exponential decay. And now we spent quite a bit of time on quadratics. We're going to compare the differences and similarities between the three. And there they are. And they all have a parent function. Linear, y equals mx plus b. You know that. Exponential, a little bit newer for you this year, but it's y equals a times b raised to the x power. And the quadratic is what we're working on right now. So what we want you to do is be able to identify which function is which from a table. Okay, so when you do that, linear function, you've done that many times. If the x value increases by a constant amount and the y value increases by a constant amount, it is linear. Okay, common difference, linear. That way you can get the slope and y-intercept from there. You know that. Exponential, a little bit different. We still look at the difference of the x values increasing by 1, but down here, you tell it is a common ratio. It's being multiplied. It's being multiplied by 2 each time. It's not adding. It's not a common difference. It's a common ratio. Now, since b, in this case, since the ratio is greater than 1, the numbers are increasing. If this number was less than 1, it would still be a ratio, but you're multiplying by a number less than 1 and greater than 0. So that's how that is going to work. Now let's go to the next slide. Now comes the new part. We've done this before. The new part is a quadratic. How do you know if don't peek, there you go. How do you know if a table of values is a quadratic function? What you look at is, again, the x values are the increasing by 1, or same amount, and they are. So now let's look at the y's. So we'll do what we did before, look at the differences. -1, -2, well, that's going down by 1, then you're going up by 1. It doesn't make much sense. So if I did my differences, I get it is increasing by 1, up by 1, up by 3, up by 5. It's not a common ratio. It's not a common difference. What is it? Well, let's do it again. So when I say let's do it again, let's go ahead and look at the differences again. The second difference. So I go -1 and 1. That difference is 2. From 1 to 3, wait, that difference is 2. And from 3 to 5, that difference is 2. The second differences are 2. That is how you know from a table of values if a function is quadratic, if the second differences are the same. So for quadratic equations, the second differences are constant. So from your tables, and this is all in your book, I did not make this up, obviously. You take a screen picture of this if you want. These are your 3 table of functions and how you can tell which ones they are. So obviously, what we're going to do is show you tables, and you have to determine, is it exponential, is it linear, or is it quadratic? And there's common difference for linear, common ratio for exponential, common second difference for quadratic. And then comes the harder part that may be a little bit tricky for us, but we can do that. It is writing a function. Writing functions from tables. Now, there are 3 kinds of, that is not the slide I wanted, the slide I want. Let me see if I can change this here. We're going to write functions from tables. There are 3 functions. The first one is a linear function, y equals mx plus b. Let me move this so you can see it. There it is. I am not going to spend any time reviewing with you how to write a linear function. You know that very well. You can find the slope, you can find the y-intercept. The only thing I warn you about is, of course, that negative slope gets in there. But we want to write functions for a basic exponential function and a quadratic. For exponential, there's my exponential function. Pretend you didn't see that. Exponential function, that is the format there. Y equals a times b to the x power. You need to know what these constants are. The b is the common ratio. The a is the starting point, or what the value of of y is when x is 0. So if you look at this table here, we see it is a exponential function. The ratio is 2, and when x is 0, the graph starts at 4. So to write the function, we have the two variables. We can find out what they are. A, it starts at 4, and the ratio b is 2. So to write that function, when you find those two things, it would simply be, wow, my picture's in there. Can I move my picture out? Oh yeah, very good. A is the starting point when x equals 0. So for this function, I thought I had the, oh, there it is. For this function, is y equals 4, the starting point, times 2 raised to the x power. So that's how you write the function for an exponential. We've done that before. Find the ratio, find the starting point. But now comes the new one, and that is, how do you find the ratio of a quadratic? And let me cover all this up. So the quadratic formula is right here. Y equals ax squared plus bx plus c. I'm not going to have you write that function. We're going to pretend the b and the c are 0. So all we are worried about is we're going to write y equals a times x squared. Now don't be confused. You know what this is. I'll put that off to the side. These look very similar. This is your exponential function. A is the starting point, b is the ratio raised to the x power. This is the quadratic function we're going to write. The way you can tell the difference quickly, look at the x. It is an exponent, therefore that's the exponential function. Down here is the beginning of the quadratic. All we want you to do is write the equation in the form of y equals a x squared. When you look at this, you'll see in this one, the exponential, and in the linear, we have two variables that we don't know, m and b, a and b. But in the quadratic, we only have one. It's the a. So can we figure out what the a is? That's what we want to do. How can we do that? What are the x and the y? The x and the y are every ordered pair. So in this table right here, here is our table. We want to write a function for this quadratic equation in this format, and this is what we have. We don't know what the a value is, but we do know every single ordered pair. We have 5 of them here. We have 5 ordered pairs. You put in the ordered pairs. So let's do the easy one. If x is 2 and y is 1. If x is 2, what's 2 times 2? 4. Y is 1. To get the a, we divide both sides by 4. 4 divided by 1 is 1/4. So a is 1/4. This function would be, we use this format right here. We plug in the x and the y. We solve for y, and we have y equals 1/4 x squared. It is that simple. And that will work with any of these ordered pairs. So you basically are squaring the x value and multiplying it by a. Let's see if that works. X squared, 4 times 4 is 16. 16 divided by 4 is 1/4. It does work. 6 times 6 is 36. 36 divided by 9 is 1/4. So it does not matter which ordered pair you find, you insert it in there. And that is how you find the function write the function for a quadratic. So today's assignment is right here. We just watched the 8.5 video, page 440, 14 to 24. And just like last week, there are 2 assignments this week, so we'll make it 4 points. Correct with the given answers and write down the answer to question 24 along with your 1 to 4 rating. So that's it for the first half of the week. Thank you, and I kept it under 10 minutes, barely. Yeah, take that back. It wasn't under 10 minutes, but it will be. The last slide, I think I said to find the quadratic function, you square the x value divided by y. That's not correct. You square the x value, divide both sides by that square, which means you're taking the y value dividing by the x squared. Okay, I misspoke on that. I know my brother's going to see that and give me a bad review. So 2 seconds, I'm done right now.